Alrighty, so what I'm going to attempt to do in this video is to relate Dalton's Law, which is all to do with pressures, with the ideal gas equation. So I'm going to talk about both of them and then how they relate, and then in the following video I'm going to try and implement just an easy worked example of how a problem might arise and how we might solve it using the equations that I'm going to generate here. So once again, these equations are going to be Dalton's Law and the ideal gas equation, and also how they relate to each other. So what we've got, I'll go through Dalton's Law first. So Dalton's Law is P, T, which is the pressure total, that equals the partial pressure, so partial pressure of whatever substance A is. That could be oxygen, could be nitrogen, whatever it is. So that equals partial pressure of A plus partial pressure of B plus partial pressure of C, and so on. So the total pressures basically equal the sum of all the pressures of each different molecule. If we were to put them all into one box, so say we've got one box here, we've chucked in pressure of A, so that's maybe, so we express it in torr, 200 torr, 300 torr. If we squeeze another object into there, there's going to be even less room. So if we squeeze partial pressure of B in there, so say it's nitrogen, if we squeeze all the nitrogen in there as well as the oxygen, now we've got two, but there's not as much room. So there's going to be less room. That's going to increase the pressure. I hope that makes sense. So pressure of B. So those two pressures added together will give you the total pressure. So pressure total will equal the pressure of A and B put together. I hope that makes sense. So that's if they're in the same volume. So what the ideal gas equation, ideal gas equation. So with that one, it is PV equals nRT. Now when I first looked at that, I thought, my God, that looks a bit scary, but it's actually not too bad. So P stands for pressure, V is volume, N, so the N is your number of moles, so hopefully we understand moles. If you don't understand moles, I'll do a video also on stoichiometry, which will explain the role of the mole and where the moles come from. But moles are very important to know for chemistry and the GAMSAT in general. This R is going to be a constant. So what I mean by a constant is that it's going to be a select number. So that select number will be dependent on the units of measures used for pressure, and so on. So you can look that up. And T, you might have guessed, stands for the temperature. Okay, so all of these factors are what will influence the pressure of gas. Okay, and likewise, if you're given these other variables, so say you're given P, V, and N, you'll be able to work out what the temperature of that system is. Okay, and if you want to know the volume, but you've got the other three, okay, you can work out volume. Okay? So, you can also find, so this is important to pick up, and I'll say it twice, you can also find the partial pressure of a gas if you know the mole fraction. So I'll say that again. You can find the partial pressure of a gas if you know the mole fraction. So what is the mole fraction? This is another equation to know. So the pressure of A, so say we were just working on P of A, this one here, up there. Pressure of A equals the mole fraction, written as an X of A, mole fraction of A times the pressure total. So the pressure total is there. So the mole fraction of A times the pressure total. So we've got those. So what is the mole fraction? The mole fraction equals the number of moles of A divided by the total number of moles. So say you've got 5 moles of A, there's 5 moles of a substance of A, and there's, in the total system, in the total lot, there's 10 moles, so there's 5 moles or of another substance. You know the mole fraction will be 0.5. Okay, so say you've got 5 moles of A, and then in the whole total, you've got your 5 moles of A plus, say, 5 moles of another substance. That'll give you 10, right? Which will equal 0.5. So that will be your mole fraction in that scenario. Alright. So we've got our equations here. Or another way that the mole fraction can be written is the mole fraction of A can also equal the pressure of A divided by the pressure total. Okay, that is also equivalent. So I'll just go down there. So you've got the mole fraction of A equals the pressure of A divided by the pressure total. Alright, so feel free to go through those equations in your head a little bit more and know how they are formulated. If you've got any questions, ask me. Just type it in the comments, like the video, subscribe, all of that good stuff. And yeah, this is also going to help me learning. So if you've got a question, it's going to help me further my own understanding by answering your question. So there is no dumb questions, and we're all here to help each other. So that's how this works. Yeah, so I'll do another video now, working through just an example problem so we can see how that might look.